will be witnessed by or examined by Mr. Goyal. He is Mr. Goyal, Ravindra Kumar Goyal. Okay.
Hello.
Then Secretary is Swapnil Joshi. Mr. Goyal is from Indian Railway. Huh?
Okay.
He is from Indian Railway. He is C in Central Railway, Chief Engineer. And then on left side, you can see Engineer Atul Bobe, very senior and the founder of IIB. Member.
Hi, Adrian. How are you?
Hello. How are you? Are you well?
I am. We are good. As good
Very
as can
good.
be.
Good. Good. Good to see you again.
Yeah, same here.
There is a Deepika Singh, another engineer from. She is a civil engineer doing in project management, working with Swapnil Joshi. Then Ruhi Agrawal. Okay, she is a coordinator. All your mails and everything has been responded by Ruhi. Hope Dupte sir has joined or not?
Manjure sir is there.
Manjure sir is there. He's a senior mentor, or you can say godfather in rehabilitation in India, or you can say in the world also. Okay, so these are the people, and people are very keen. In fact, we got confirmation of 140 people registered for the lecture. That's a good number.
Yeah.
And this is a topic we never address, waterproofing in bridges. So you are the first person, and you are setting the benchmark.
Oh, no pressure then.
So, and myself, Dr. Gopal Rai, I am the moderator for this webinar. Okay.
Thank you very much. Thank you.
So over to you, Swapnil. I think, sir, Vinay Gupta, sir, shall we start?
Oh yes, please go ahead.
Yeah.
Okay.
Oh.
I'll
Sam
just.
broadcasting.
Thank you.
I'll have to leave you soon because of my other meeting, which is starting now.
Yes, sir.
I think you can start. Broadcast.
I'll just share my screen just a minute.
First, Ruhi will share. We have certain slides to show, and then
we will invite Mr. Pike.
Yeah.
Mr. Pike, invite you. There are certain procedures are there. Introduction of everyone.
Okay.
Then we'll invite you. You be there.
Okay. Very good.
Okay. I think Swapnil, all yours.
Yeah, I think Ruhi, Deepika, you can start.
Good evening, everyone. We welcome you all to IIB's lecture series. Today we have with us Mr. Adrian Pike, who will be presenting on Introduction to Technologies, Codes and Methods of Bridge Deck Waterproofing System for New and Existing Bridges. Going ahead with this, I may now request Madam Ruhi to present the guidelines for the event.
Thank you, Deepika. Good evening, everyone. Before we start the event, I would like to read basic rules and guidelines for all the participants. All participants will remain on the mute mode during the lecture. Questions should be put in the question answer stroke after the lecture by the speaker. Questions will be replied by the speaker, panelist. Subsequently, attendees can raise hand from the option below at screen. During questions, specific participants will be unmuted by the organizers. After the participant's question gets over, the participant should mute himself. Participant's video will not be displayed on the screen. Speaker, panelist can share screen. Now, I would like to introduce our Honorary Secretary, Engineer Swapnil Joshi, our host for today. Swapnil Joshi, an intellect who possesses bachelor's in civil engineering and double post-graduation from United Kingdom and NICMAR with specialization in construction project management along with law graduation. He has wide exposure in developing systems, has developed expertise in the field of CPM combining technical and latest management tools such as Primavera, ASTF, Power Projects, Telos, etc. He initiated and developed a mobile application, Nintendo Projects, for daily monitoring and real-time data analysis of projects. With successful implementation of digitalized integrated approach and his expertise in project planning, BEAM, and advanced technologies, he is able to deliver the client's goal successfully. Swapnil has been rewarded by Indian Institution of Bridge Engineers from the hands of Sri in 2014. Now, I would like to hand over the event to our host. Thank you so much.
Thank you, Rui. And I formally would like to welcome all the participants, all the panelists, our esteemed speakers, and members of IIB. And uh, for today's number 8, introduction to technologies, codes, and methods of bridge break waterproofing system for new and existing bridges. Now, before going further, let me just introduce give you a background of IIB. The Indian Institution of Bridge Engineers is the only institution deals with bridges and was founded by late Sri Engineer MC Bide in 1989, aiming to disseminate the knowledge across the globe on bridge engineering. After its sad demise on 7th of July 2018, IIB strives to continue to promote bridge engineering with the same enthusiasm and passion. IIB is spread over 33 states and local centers with about 7,000 strong member force and 169 institutional members. IIB has created laurel for the country and has published more than 29,200 technical literature, which is available for the members online as well. With, Louis, can you go next? So, so basically now that we are after engineer MC Bide sir, we have two pillars of IIB along with other senior members supporting the whole institution and its great work. So let me introduce our Director General, Engineer DG Dute. Engineer DG Dute has graduated in civil engineering from College of Engineering Pune in 1974. He has joined Indian Railways Railway Service of Engineering (IRSE) as Class 1 officer and retired as Chief Engineer of Indian Railways in 2011. During his service, he has worked on many important railway projects. He occupied the important post of Principal Chief Engineer, North Eastern Railways and South Western Railway, Director, Konkan Railway Corporation, Chief Engineer, Konkan Railway Project, Chief Manager of Tunnel from Mumbai to Pune Expressway. He has also recently was involved as CGM on Mumbai Metro 3 to 33.5 kilometer fully underground stretch. So he's a great support for IIB, our Director General. Now let me go to next slide. Let me introduce our President, Engineer Vinay Gupta. Ravi, can you just go to next slide, please? So President Engineer Vinay Gupta is a civil engineer from BITS Pilani, 1983 batch, and is a director and CEO of Mrs. Tandon Consultants Private Limited. His specialization is spread over bridges, flyovers, underground and elevated metros, precast buildings, 275-meter tall chimneys, etc. He is an active member of various board committees of BIS and IRC. His contribution include preparation of IRC SP 65, IRC SP 71, etc. And he is a recipient of several awards from IEI, IBC, and UKI ERI. He has been lecturing as a guest faculty in various institutions as well as the organizations in like IIHE, CRRI, CIDC, etc. Engineer Gupta is an Vinay Gupta is an president, All India President for Indian Concrete Institute and our own Indian Institution of Bridge Engineers as well. So these both pillars are a great support for IIB to grow further. Now let me introduce our today's moderator, Dr. Gopal Rai, Honorary Secretary of IIB and CEO of Dhirendra Group of Companies. Dr. Gopal Rai holds a PhD from IIT Bombay and has a phenomenal level of prowess and enabled him to associated with several prestigious projects including Apsara Reactor BARC, Mumbai Airport Bridge Strengthening of Mitti River, ESIC Hospital, JNPT ROB Bridge, etc. He is a Honorary Secretary of IIB, General Secretary of Association of Structural Rehabilitation and Retrofitting, Committee Member of ISAC, BIS and ACI. He has delivered more than 680 presentations nationwide and 27 presentations internationally. He also has been a keynote speaker and author in 4 international conferences and published more than 100 numbers of his research papers in various journals. Dr. Gopal Rai has also been awarded for 50 Manufacturing Innovative Leaders at World Innovative Congress Award 2019 and also in Dubai for 40 Most Influential Leaders under 40 years 17-18 by Asia One and many more. With this, brief introduction, I would call upon, I'll hand over the question for today's moderator, Dr. Gopal Rai. Gopal, over to you.
Yes, Swapnil, can you hear me?
Yes.
Thank you, Swapnil, for your brief introduction. And hello to all the uh, participants. I know this is the subject from purely structural engineering, from long span, bearing, expansion joint, cable, and finally we have come to the talk, which is most awaited, and like all the repair and everything the begin if water penetrate inside the slab or anything. Okay, so before I go to the subject, we have today the panelist. Hello. Yeah, Ruhi. We have today the today's panelist for the talk is engineer Ravindra Kumar Goyal. He is an IRSC officer of Indian Railway, 1988 batch. He has long experience of design, fabrication, construction, and maintenance of railway bridges. During his long working at BNS, DT, and RDSO, he had worked on various projects with different IITs, received and fatigue provisions in IRS Steel Bridges Code and development guideline of seismic design of railway bridges. He holds special diploma in bridge engineering from MS Rambol, Denmark. As a also he has served as a chief bridge engineer in Central Railway, and he has dealing with approvals of design and drawing for road over bridges. He has issued comprehensive guideline of design, fabrication, inspection, and maintenance of FOB on Central Railway. He has also associated, yes, if I will say from last, like every lecture, like one of the keenly interested, and he listened to all the presentation and everything, and he's one of the like a pioneer member in IIB, and really we are looking for Sri Engineer Ravindra Kumar Goyal ji for your accepting as a panelist for today's. It's a very valuable subject of waterproofing of bridge deck. So request all to be there, and the whole lecture will be supervised by Engineer Goyal. Rui, over to the next slide. Yes, the most awaited, the topic, introduction of techniques, codes, and method of bridge deck waterproofing system for new and existing bridge. Before I go to the speaker with Engineer Adrian Pike, this purely the subject and the speaker and all. One of my close friend, or you can say a colleague when I was in BSF, I think Anil is also there, Anil Anjappa, who has requested, and then we told yes, this is a subject which need to be taken for the bridge engineers also, and it's a very important subject of waterproofing of a bridge deck. Okay, so looking at that and looking at the engineer Adrian profile. Okay, let me read out the profile of engineer Adrian Pike, an UK national with over 30 years. Wow, the experience in bridge deck structural waterproofing. Yes, the word always the structural, the waterproofing also is a part of structural only. If you don't do it properly, then it become a structural problem. So very correctly told. A former vice president of United Kingdom, UK Bridge Deck Waterproofing Association, and member of National Technical Committee NTC 18, which assisted in development and harmonization of standards for bridge deck waterproofing across Europe. He is based out of Dubai, UAE since 2006. Right now, he is holding a post of Vice President USL Tramco, Dubai. Okay, so he is holding that post. So without taking much time, uh, let me request like today's panelist to give some few words, and then we'll start with uh, the talk. Over to you, Mr. Engineer Goyal.
So thank you very much, Dr. Gopal Rai. First of all, I am too excited to see that this topic of bridge deck drainage, waterproofing of bridge deck, has been chosen by IIB for a special lecture series. In fact, as a chief bridge engineer in Central Railway, we have got about 89 ROBs audited for their structural safety. And we have noticed that wherever there were problems, the problem was basically because of the poor drainage conditions near the curb line. And all the girders down below, they were having the problem of corrosion just because of the seepage from the bridge deck. So this topic has been a very, very important topic for all the bridge maintenance people, and particularly for the Mumbai area. This is a big problem. And the good thing is that you have taken a comprehensive look. You have taken the design, maintenance aspects also into the topic. And I am very excited to see what kind of solutions are being suggested by the speaker. So with these opening words, I request the speaker to kindly take
I
on.
think, now we should formally begin with the talk. Engineer Pike, over to you. Hope the presentation has been downloaded. Ruhi or Deepika, can we request the speaker to begin?
Yes, yes. He has already he's
Yes,
going to
sir.
present the screen. Only video is Arun.
First of all, welcome to India, sir.
Thank you so much. Thank you so much. It's an honor and privilege to be here. Just a first thing, can everybody see the screen? Can just somebody say yes?
Yes.
Okay,
we can
very
see,
good.
yes.
That's the first task completed. So that's very good.
Your voice is also very good. Go ahead.
Okay. Thank you very much for the introduction. Bridge deck waterproofing is often overlooked. There are literally billions being spent every year on infrastructure development and maintenance. And there are a lot of countries that often ignore this principle. They would prefer to just use asphalt or strengthened concrete to actually waterproof, but rather than doing anything at all. But bridge deck waterproofing has been used in the UK since 1945, when it became mandatory in 1960s. And now it's the technology is used throughout the world, really. No matter what climatic condition you're in, bridge deck waterproofing is generally used to protect the infrastructure. The last thing you want to do is to build a brand new bridge and not protect it from the elements. Otherwise, you'll end up with problems. Okay, so I'll just move this on.
Yeah, there is, I think the PPT is missing. Deepika, can you check why we cannot connect PPT?
You have not changed the slide, right?
Yeah, okay.
Now it's changed. It is okay. It's working.
Can you see that, hopefully? Okay.
Yes.
Okay, so today's talk will cover these elements. The reasons why we're doing waterproofing in the first place, which is the fundamental one. Some of the standards that are used internationally, both the UK and the regional Indian standards that have been used. How the systems are installed. Some of the QA, QC measures that are imposed to ensure they're installed correctly. I look at some case studies around the world. And finally, I'm really open to questions and answers from the panelists and anybody listening today. So very, very quickly on our business. USL Group is part of the RPM business. RPM is a North America-based conglomerate that specializes in chemicals and sealants. And included in that is Tremco. Tremco are our local partners in India with a regional presence here for maybe 20 years now. You can see the different operating divisions there: construction products, performance coatings. Tramco are in construction products, and USL are in performance coatings group. But we're both working together in India to try and promote good practice and technology into the Indian market. Here's one of the facilities of Tramco in India, in Chennai, where they do manufacturing and production of various different construction chemicals. There are many, many different types of bridge. Most of these have been adopted in India, and they've all got the same problem. They're all will suffer from degradation, from corrosion, unless the bridge decks are adequately protected. So that's really the main aim of today's talk. It's not really to talk about any particular method. It's to give you a general overview of the technologies available and how they're installed, and most importantly, how they're going to ensure that the life of the bridge will be extended, which is what the subject is all about. This is often a common method of construction as segmental concrete bridges. And again, here, it's very important that the bridges are protected because they are subject to cracking. Concrete will do two things. It will go hard, it will crack, and where the cracks are formed, moisture and other contaminants can enter the structure, causing problems with corrosion. So it's very important that the decks are protected. The ultimate failure mode is collapse. Now, I don't want to frighten anybody, but obviously we've had issues in the UK, in America, obviously in Europe recently, and in India. This is not, thankfully, a common occurrence, but if there's lack of maintenance, lack of inspection, and lack of forethought for the materials used, then problems can and will occur. So typical elements of a bridge include the bearings, the protection of the bearings, the expansion joints on the bridge deck, drainage. It's important that all the rain that you encounter in India is dealt with, and the water is taken off the bridge as soon as possible, and also the waterproofing of the bridge decks. So the question's often asked, certainly here in the Middle East, where we get rainfall perhaps 2 weeks a year. Why do we need to waterproof structures? It hardly rains, we're in a good climate. Well, these are some of the reasons. Clearly, there are extreme temperatures. Here in Dubai, we can reach 50 degrees, and that's often the case in parts of India. There's airborne contamination, that's from chemical pollutants and also from the surrounding marine environment. And obviously waterborne contamination, which will take contaminants into the structure, causing corrosion and remediation problems. And this is the effect, really. We all know that reinforcement can suffer from corrosion. Yes, there are different methods that can be used to protect it, but ultimately you've got about 50 millimeters cover to protect the steel, and the concrete will crack and it will allow water through it. So unless there's a suitable membrane above the deck, then the rebar will become exposed. Medium term, you can get deck fragments to be destroyed. The concrete will spoil, asphalt will pothole, and you will end up with extensive repairs to the bridge. And that's not only the cost of doing the repairs, there's also the bridge access. Obviously, you are stopping traffic on the bridge. You may be reducing the loading. You may be reducing the service. But ultimately, it costs an awful lot of money for the bridge owner if he suffers from corrosion and degradation. So it's a very important subject. And if it's not dealt with today, then maybe in 10, 20, 30 years' time, you'll be faced with quite a large headache, which is happening at the moment in America, in parts of the UK, and in Europe, where waterproofing has been an afterthought. There are many different systems available to protect bridges. The company that I work for is USL, but Pitchmastic is a subsidiary. The name Pitchmastic comes from bituminous type materials, and we've been involved in that for about 70 years. But systems have developed. Like anything else, technologies move forward. The problems that you can get with bitumen systems are they're typically about 1 meter wide. So everywhere there's an overlap, there is a potential weak spot for water. Water will find the weakest spot, and that's generally the overlaps or details. And if you've got quite a thick, rigid sheet system, then it's very difficult often to get an adequate seal. So they can be problematic. Also, in hot climates, clearly, if you're putting a bitumen type material down that will tend to soften under the heat, if your surface temperatures of the deck are pushing 70 degrees, then you're going to get some problems with slippage. So it's very important that the material used is not only suitable for bonding to concrete or steel in that case, but also for bonding to asphalt in all sorts of different conditions. So it's not just about bonding to the actual substrate. In addition, some systems are vulnerable to damage during asphalt. Most bridges are subject to asphalt being laid afterwards. Obviously, the pavement typically is 2 layers. The first layer is laid over the waterproofing. If the waterproofing suffers from damage and puncturing, then clearly the waterproofingness of that material will be void from day one. I mentioned briefly before about compatibility and bonding to asphalt. This is probably one of the main causes of failures. Often testing is done for bonding to concrete. And if the bonding is good, the material is approved. But the main stress comes from the traffic. The traffic is going over the asphalt. The asphalt might be 5-6 centimeters thick. And every time a vehicle brakes, there are tremendous forces imparted on the asphalt and obviously the waterproofing beneath. So if there isn't sufficient bond and compatibility, you will get slippage. And in hot climates, it gets worse and worse. And these are a couple of examples of what can occur where the bonding is problematic and the client's got headaches very quickly. He's got to put repairs in, which leads to other problems, and the overall suitability will quickly fail. So it's very important that you get compatibility with asphalt. Other design considerations are abrasion resistance. Clearly, the waterproofing system is going to be subject to heat, some traffic. There's going to be vehicles over the membrane during the construction sequence. Crack bridging, as I mentioned, the minimum requirement in the UK is 1 millimeter crack bridging. In Germany, it's 2 millimeters. And in some parts of the world, they're expecting at least 3 millimeter crack bridging. So that is a very important consideration for any system. You can read the others, but clearly installation speed is important. You don't really want a system that will take weeks and weeks to put down and needs perfect conditions and everything else when you have temperamental conditions. In India, you get hot days, you get cool days, you get rainy days, you get dry days. So you need systems that can be installed within quite small weather windows in order to get productivity. So I now talk about specifications, and these can vary around the world because there are different requirements around the world. There are cold climates, there are warm climates, there are wet climates, there are humid climates. So each country often have a different requirement for the membranes. I'm based here in the Middle East, where it's probably one of the hottest countries in the world, but they they generally specify a mixture of UK standards for the waterproofing and some ASTM standards. But the one highlighted there is called BD47, which has been the national standard in the UK for 25 years. And this involves a lot of testing, not only with the waterproofing, but also the asphalt, the bonding to concrete, resistance to chemicals and fuel oils, freeze thaw, heat impact, etc., etc. So it's considered to be a good benchmark for any quality of a system. So it's put in specifications because at the very least, if it's met those requirements, they know that the membrane is going to be a good, durable system. But that's not the only thing they're looking for. They're looking for systems that will work in that particular climatic condition. There are also esteemed bodies such as the Concrete Society that are recommending the use of high-performance waterproofing systems, which in their view will provide the structure more durability, which is what it's all about. And they're mentioning there that they should use different equipment, pinhole detection equipment, which I'll go into later, for making sure that the system is completely integral. In America as well, they have learnt the hard way, really, that doing nothing on a bridge deck will cause you problems in a later day. So now there's a lot of new standards and specifications being issued, certainly in the northeast of America, where they have adopted some of the technology and the experiences that have been encountered in Europe. And here's an extract from the Federal Highways Bridge of the Future that we were involved in about 17 years ago. And as a result of those extensive studies and reviews, they made some significant changes to the specifications, to the testing, to the asphalts used and the waterproofing systems used in the north of America. I'm now going to talk about the types of sort of high performance or higher technology systems available in the market today. These can be spray applied or applied by a squeegee. And they are, some of them are similar technologies, some are different. There are systems called Puma, which is a blend of polyurethane and methyl methacrylate. And this provides a fairly good blend of performance at different climatic conditions, but they're generally applied by roller. The polyurethane system there on the left is a spray applied system, very quick curing. So generally the PUs will cure within seconds, really. They'll gel in about 5 to 10 seconds, rainproof within about a minute. So quite suitable for periods where the weather conditions might change dramatically. Methyl methacrylates, again, these are generally spray applied, applied in 1 or 2 coats to achieve the minimum requirement. And again, they've got durability, very good bonding for steel as well. So they're quite well used for steel structures. I mentioned about the BBA before. The BBA is the British Board of Agreement, and these are the UK government's testing house or testing authority. And they're recognised around the world that the BBA is often used for testing a variety of construction materials. And in our world, it's testing of the bridge deck waterproofing materials. And the HAPAS standard is very, very stringent. It takes the BD47 standard that I mentioned before to another level. And it includes a lot more specific tests related to application to maintenance contracts. So the concrete won't always be smooth. So they do testing on uneven concrete, on irregular concrete surfaces. They use different types of asphalt. There's not one type of asphalt used in the UK or around the world. So they use different types of asphalt to verify suitability. They also do things like overlapping tests. So obviously, if you do a bridge today and have to do the next phase in 6 months' time or a year's time, you need to know that the two layers will be compatible. So they do aging tests on the material, again, to verify its suitability after a few months or a year in exposed conditions. The standard also includes a field study. So rather than just doing lab tests, they actually, or the manufacturer has to verify that the material will work in service. So it's put on a bridge. There has to have at least 20,000 vehicles a day movement. And then it's inspected over a 12-month period. And only then, and subject to the completion of the lab results, is it given certification. And then it's followed up by 6-month reviews and then a 3-year audit, which involves taking up of references, inspections, factory audits, etc., etc. So it is quite an in-depth sort of 365 review of the system and also the application. Obviously, because the material is only ever as good as the application. So it involves auditing the installer, the people that install the materials, because, without good installers, we're all wasting our time. So that's very important as well. And here's obviously some more information on the systems. There's a point there about, in the UK, we used to have a previous standard called BE27. And at that stage, there was about 25 different systems approved, a variety of bitumen systems to the high performance. Once the new standard came out, there's only now 3 or 4 different systems approved. So it sort of reduced the number of systems available, but the client was happy because he knew that they would provide him durability, which is the most important thing, because the UK were wasting a lot of money on waterproofing that wasn't durable. So they were doing maintenance works, within 3 or 4 years of actually laying the waterproofing. So not very cost effective. Just some of the testing that has been done that's relevant for bridge applications. This is a puncture test, so it's really to check that the membrane can withstand the rigors of a bridge application. Obviously, it's going to be subject to trafficking. It's going to be subject to site vehicles and perhaps some concrete curbs being laid. So this involves putting a 100 kg per foot load over an unsupported membrane. And you can see there the load has gone through, it's pushed the membrane down, but it's not broken the membrane. So it shows good resistance to damage, to puncture resistance. Crack bridging ability, again, it's very important that this is selected as part of the requirements for jobs, because if the membrane is stiff or it's rigid and can't withstand the service conditions, then cracks will form, water will get in, and the membrane is superfluous. This just shows you that you can use thin strips to give increased crack bridging ability. Most membranes, certainly the polyurethane variety, will give you about 5 millimeters crack bridging ability, and that can be extended by applying 2 layers of the material and also using a debonding strip. For railways, obviously there's no asphalt, but there's tracks and there's ballast. So in order to verify that the ballast will not have any significant impact on the waterproofing, the UK does a ballast indentation test. And this involves about 2 million cycles of load under 41 to 185 kilonewton testing, which is equivalent to 25 tons. And once that's done, the membrane is inspected, and then it's subject to a hydrostatic test to verify there's no leaks or mist areas in the membrane. So again, very severe, but again, if you're doing a railway, there's no time to repair. You know that you'll just disrupt the traffic and the service. So it's very important the installation is done correctly. Climatic conditions. There are many manufacturers, UK, Europe, that have great systems that work very well in Europe. And but India and the Middle East is not Europe. The conditions, the humidity, the air temperature is completely something different. So it's important that anything that's adopted locally has a good track record. It has proven durability in these climate conditions, rather than just coming along with a test certificate from Europe. Just a quick overview of the systems and some of the pros and cons, if you like. You know, the PUs and Pumas are generally more flexible. So they're for concrete, perfect. For steel structures, often the MMAs are used because they're quite the more a stiffer material and they're more compatible with the steel. So again, it's a variety of mixes that is used. Yeah, I mean most of the systems are good for bonding to concrete or steel, which is a given. But also there are different methods of application. There can be single or double thickness. But storage and handling is an important one. Obviously, if you're doing a bridge, there might not be sufficient areas to store the materials under cover. And if you've got to put in special storage conditions, air conditioning and whatnot, it can be very expensive. So some of the materials need special storage. Some don't. So that's, again, an important consideration. Depends on the size of the job. Depends where it is. But again, it's something worth looking at when you are looking at different products. Now a quick look at a typical application method. So you have a concrete or steel substrate, and the most important thing is preparation. Unless the concrete or steel is cleaned and it's free of any contamination, any latents, any oil, grease, or other materials, it simply won't work. The bonding will fail. The asphalt will pull the membrane off the deck, and you'll end up with maintenance from day one. So preparation is key to any performance later on. Then typically there's a primer applied over the concrete surface, followed by the waterproofing, and then a degree of bonding medium to the overlay, and then the asphalt material itself. The first operation really is to make sure that the surface, if it's a new concrete structure, we need to make sure that the moisture is at a certain level. Too high moisture will result in poor bonding. So generally the rule of thumb is about 6% surface moisture or less. So we do that check before we apply the waterproofing system. And we also check for air temperature, relative humidity, and dew point. I mentioned about preparation, and I will mention it again. It is vital for any system to work. So generally speaking, if it's a large area, you will use vacuum blasting. It's much cleaner. It stops the overspray of grit into the marine areas. It's quick. For areas that have got existing waterproofing on, you'll need to use grinding or planing of the surfaces. For small areas, intricate areas, you may need to use grinding or sandblasting. All of these are suitable, and the end result, it needs to be clean, dry, and free of any loose materials. So we then commence with a primer, which can be applied typically by a roller or airless spray. And this is the first line of defense for bonding to the substrate. Then your waterproofing membrane, typically these applied at minimum of 2 millimeters thickness, and they can be built up in layers of 1, 2, or multiple coats, depending on the client's requirement. Spray machinery, again, this can vary according to the type of system that's installed. There can be high pressure machines or low pressure machines. Again, it depends upon the manufacturer's requirements, but certainly some of the machines are designed to be very strict in terms of the control. The last thing you want is to apply a membrane that's not in the correct ratio. So some of the machines have an auto cutout function to stop the material to be applied out of ratio, which I think is a very good idea, and it will avoid any installation error, which are often caused with materials being applied without the correct ratio. One of the key benefits of a liquid sprayed system is dealing with imperfections in the concrete surface. There's no concrete in the world that's perfect. There will be irregularities, there'll be blowholes, there'll be footprints, and you name it. Now, there may be repairs required, but generally speaking, in hot climates, you have to be very careful when you're doing repairs. If you're using cementitious materials, for instance, they will cure very quickly. The water will evaporate, and it often leads to cracking and the inadequate curing of the material. So yes, you can use epoxies, but often these repair areas can be lined out with the material, with the waterproofing material. So it will mean a quicker application, and also it means that you're bonding to the actual structural deck itself rather than a potential weak bonded repair. In order to make sure that the correct thickness is applied, we go through a series of checks now, which can be inspected by all the relevant parties, from the client, the consultant, the main contractor, and the waterproofing applicator. And the first one is a thickness. So here we're doing a thickness check using a micrometer, and we're taking out a sample of the membrane in its semi-cured state, making sure that the thickness is the right 2 millimeters thickness. We then do tensile bonding checks on the membrane. This is generally done within 1 or 2 hours from application, and we're using typically an alcometer or similar test device, and this will exert a force on the membrane above the concrete, and what we're looking for is cohesive concrete failure. And generally speaking, we're getting about a minimum of 1 megapascal or 1 Newton per millimeter square after about an hour. So as long as we see the concrete pulling out, we're happy. So it all depends on the preparation, which is, as I mentioned before, very important. The final test that we do is called a pinhole test, and this involves applying a high voltage DC stray through the membrane. If there are any mist areas or leakage paths, the equipment will bleep, and that will signify a leak or a mist area. Those areas are repaired, and that completes the cycle. So at the end of those operations, the client knows that the membrane is of the correct thickness, it's fully bonded, and it's completely integral. And that cannot be said of many of the traditional types of systems. So that is one of the main key differences between the more modern spray applied and high performance systems compared to other varieties. I mentioned before about the necessity for bonding to asphalt. The traffic loads in the Middle East and in India are often 100 tons. The axle loads are far, far greater than Europe. So the pressures and the shear forces are that much greater. So the use of a shear mechanical layer is considered very, very beneficial for the durability with asphalt. This generally involves a separate layer of primer or bonding medium, and then it's broadcast with aggregates to give a mechanical key to the overlay. Finally, a bitumen or a tack coat is applied, and these, for them to be durable, need to have resistance to heat, clearly. They need to do two things. They need to reactivate with the heat of the asphalt, which is generally between 130 and 190. And they also need to make sure they don't soften too early, too soon. As I said, the deck temperatures in India will probably reach 70, 75 degrees. So if the bonding medium starts softening too early, it will pull up under the tires, causing a mess and causing delamination problems. So it's important that the specifications are right for the market. And then the asphalt is applied over the system. I have a video to play, but I'm hoping that one of my colleagues will be able to share that for me. Is that possible?
I think Deepika or Ruhi. I think we are sharing on video.
Yes, sir. I'm sharing.
So, Mr. Paik, you work in India with the name of Tramco?
That's correct, yes. Tramco and Flowcrete have been there quite a few years. So they've got a good infrastructure in India. They know the market. They've got some good people there. So we're helping them. We're helping train their guys, offering the technical support. And it's working well as a team.
Okay. So this is like the longest span of waterproofing what you have done till date. Before the video starts, let us have some interaction. The longest one. Yes, Ruhi, you are ready?
Yes.
Ruhi, I don't think we are able to see. We are not able to see the video.
If you could play the process one, can you see the process video, the one to the right?
Rohit, click to the right one on the very next video.
The process one.
Yeah.
Not that one. No.
Not this one.
Okay, this one.
Play this.
That's it.
Less MB.
The PMB waterproofing system protects the concrete structures from the ravages of environmental corrosion and heavy usage. The high-performance PMB system is...
Deepika, do you have a video?
Well, if it's not working, guys, I'll just carry on with the presentation, yeah?
Yeah, you can continue. Let me check on the back side.
Exactly. We can.
Or I will request Anil to present the video. Anil, if you are comfortable, you can present the video also, if you have. Okay, you continue with the presentation.
Okay, thank you, guys.
Yeah. Please continue, sir.
Yeah, okay. In terms of the requirements for bonding to asphalt between the waterproofing, it is very important that there are certain parameters set. The figures here come from the UK requirements. I mentioned before about the HAPAS standard, and that included different types and thicknesses of asphalt. In India, for instance, the asphalt is probably about 8 centimeters or 80 millimeters. So the thinner the asphalt, the greater the bond requirement will be. So you can see there that both in terms of the bonding to concrete, it's 0.7 as a minimum, which we think is quite low. And then in terms of shear bonding, it starts at 0.4 and goes up to 40 degrees, which is much higher temperature, to 0.15. So you can see a sliding scale compared to the thickness compared to the result. So it is important that these are looked at, and clearly testing with local asphalts is also preferred as well, to make sure that everybody's aware that the bonding can be achieved using local asphalts and the waterproofing system. There are many different approving bodies that have used these types of waterproofing system. UK, obviously, a lot of the European bodies have got different test standards and methods, really to suit the local markets. And here in the Middle East, again, a lot of local authorities utilising similar standards to make sure they've got a good, durable system. A very quick look at the IRC, which is the new standard that's going to be issued. We're really pleased to see this, because previously there wasn't much of a mention of waterproofing in the standards. This has gone on to state that these systems are suggested for bridge decks. They've also suggesting that the systems used should have a national and international reference, which again is good. It means that there's a benchmark for the systems, that they need to meet a certain requirement. I'd like to see more information in there for the actual test requirements. Again, perhaps some reference to international standards might be useful. These are typical specifications where you're talking about ISO 9001, which is quite useful. Having the systems mentioned in terms of the type of products, how the systems are installed. Installation experience, again, is very, very important. As I said, you can have the greatest system in the world, but if it's installed by companies that don't exactly know what they're doing, it can soon turn into a disaster. So having a specification or requirement that has applicator experience, proven experience, we think is very important. And also mentioning about the QA procedures. Again, applying a system is fine, but the bridge owner wants to see that the thickness is there, the adhesion is there, and that there's no holes in it. So having these interwoven into the specs is probably not a bad idea. There are also other sort of sister specifications, if you like, SP65 and SP112, which again are good references for specifications as well. This is typically the way that the bridge would be detailed. Obviously, the membrane would be applied over the prepared bridge deck through up to the parapet level. If it's an existing structure, then it would go through any service areas, any service bays as well. And in the UK, we often do the inspection galleries and spray up to the bearings as well underneath the bridge. So it's something that might be considered useful. And then obviously the asphalt and concrete is applied above it. Again, just some examples from around the region that's talking about the system must have at least 10 years experience. It's probably not a bad thing to have, having products that have got some track record and durability. And again, I mentioned about the applicator. This is a thing that's used in Oman. where they're looking for the applicator to have experience as well. Finally, just a look at some case studies of bridge projects that have been done around the world. This is a project in Saudi Arabia. It's a steel and concrete composite project. The main steel arch bridge was actually built in Dubai, and it was shipped over to Riyadh to be constructed. And then either side there's a concrete flyover approaching the bridge.
Adrian, if you allow me to play the video, application video.
No problem. No problem.
Gopal sir, can I play the video, the application video?
If I stop sharing, you can jump on, Lavin, yeah?
Is the screen visible?
That's it, Bhavin. Well done.
Yes, sir. Yes.
Is the audio there? Is there an audio?
No.
At this time, the audio should be there.
Yeah, fine.
The waterproof protects the concrete structures from the ravages of environmental corrosion and air usage. High-performance PMB system is quick and easy to install. Surface preparation. It is important that the surface is clean, dry and free of any loose contamination. The most effective way of doing this is by means of recirculating vacuum blasting, which is quick and avoids contamination of surrounding areas with spent abrasive. Primer application. The PMCS01 polyurethane primer is applied to the prepared surface by airless spray or roller and typically cured in 1 hour. PMB waterproofing membrane is a two-component spray-applied elastomeric system which forms a seamless, watertight and corrosion-resistance barrier to protect the structure. It is rapid curing and gels in around 5 seconds. Testing. To verify the correct thickness and prove tensile adhesion. A high voltage integrity test is finally carried out to verify quality. Key coat. The bond to the overlay in the Middle East, critical due to summer temperatures, relatively thin overlays and heavy truckloads. Therefore, a two-stage process is carried out to enhance bonding. The first involves a shear resistive key coat comprising a primer and a 1 to 3 millimeter silica sand. Tack coat. The second part of the process is to apply a polymer-modified bitumen tack coat. The product is specifically designed for hot climates and has an elevated softening point of around 95 degrees Celsius. Asphalt. Asphalt. Typically 12 hours.
Yes, I have unshared the screen. Yes.
Yeah, thank you. Thank you, Bhavesh ji. Bhavin ji.
Hello, Gopal.
Yes, sir.
Okay, thank you for that, Bhavin. Appreciate that.
Video नहीं चल रहा है?
Yeah. Hello.
हाँ.
Dute sir.
Yeah.
नमस्कार सर, गुड इवनिंग.
नमस्कार, गुड इवनिंग. मैं थोड़ा लेट ज्वाइन हुआ था, बट आई ज्वाइन. बट अभी क्या प्रॉब्लम हो गया है?
नहीं, कोई प्रॉब्लम नहीं सर. वी विल कंटिन्यू विद द प्रेजेंटेशन. यस.
अच्छा.
Okay. Thank you, sir. Mr. Pail, you can go ahead.
Thank you so much. Thank you so much. So yes, I'm just going to run through a few case studies, some projects that we've been involved in around the world. You might recognise this one. It's called the Third Crossing. in Abu Dhabi. You can see the second one, which is Makta alongside it, and then there's Musafa. The Sheikh Zayed Bridge was built about 11 years ago now, so it's quite a striking Zaha Hadid structure in Abu Dhabi. Try and move this along.
Any problem in sliding?
It tends to freeze, that's all.
Okay.
Yeah, okay. Yeah, okay.
That's great.
Yeah, this is in Australia using a Puma system. So this is an existing bridge, a very busy structure in Melbourne. And what happens is every sort of Christmas period, they allow them to close certain sections to do essential maintenance work. So they give them quite small sections each year. And this has been going on for about 3 or 4 years now. So this is a small section that's being done. They just can't allow the bridge to be closed for any length of time. So they just do a small section and then move on to the next one. This is Canada. We did about 25 structures in Quebec. Interesting thing about Canada is temperatures. So you have probably similar summers to India. It probably gets to 40 degrees in the summer, but then it's probably minus 20 in the winter. So it's quite extreme in terms of the operating conditions in that part of the world. Anybody that's been in the UK might recognise this. This is now called the Prince of Wales Bridge, connecting England and Wales. It's one of the longest structures in the UK, if not the longest. And that was done 24 years ago now, so quite a long time ago. These systems can be used as wearing surfaces as well. So a combined waterproofing and wearing course can be used. So if you have situations, maybe a bascule bridge or a swing bridge or a structure that just can't take the loading, then you can put durable wearing surfaces on that are maybe 6 to 10 millimeters thick, providing quite a long service life for that particular structure. This is one in America that was done. Again, same sort of thing for a bascule bridge that we're doing at the moment. Again, this is the sister bridge to the one I showed you before, Musafa, about 24 years ago now. There's been a lot of activity in Kuwait over the past few years that they're building up new bridges and tunnels. And this was part of the Jabba Causeway job. The Jabba Causeway is the longest causeway, I think second in the world to the one in Macau. This section was 12.4 kilometers long, so it's quite a challenging job. Obviously, it's over the water, different conditions and humidity, etc. So quite a challenge. Some more current job that we're doing at the moment for AFCONs in Kuwait. A few years ago, we did the Batina Expressway, which at the time was one of the largest jobs in the Middle East. 265 kilometers of new road, involving about 85 new structures. As you can see, we worked there for L&T and Galfar and NCC in Oman. Cable stay bridges in Ireland. This is an existing steel bridge in Turkey, where, again, very, very busy traffic. So the contractor applied this system to 2 lanes, and the traffic was kept open on the rest of the bridge. So we're removing the existing waterproofing. We're preparing the surface by sandblasting, by shot blasting. And then we apply the system. And this is an overview of what we were doing. So a very, very quick program. They were only given about 2 months to complete the entire project. So very fast track over the summer period in sort of June to August to maintain traffic flow. And now there's another video here. I don't know whether Bhavin can jump to the rescue again and play this one.
Gopal sir, do you want me to play that?
Yes, sir.
Sir Bhavin here. Shall I play the video?
Yeah, please. We have shared the Excel. Yeah, please go ahead. Yeah, thank you, Bhavinji. Good. I think Mr. Pike, you can continue. You're unmute. Please unmute.
Yeah. Thank you for that. So I think we've just got a couple more slides now, guys. So.
Okay.
And one includes another video. You'll be pleased to hear.
Yeah. Can you share the screen first? I think Mr. Bhavinji, you have to.
No, sir. He has some slides and then the video will come, sir.
Okay.
His laptop is, I think, that's connection some.
Yeah.
Okay.
So we've left the best one to last, I suppose. It's the longest sea crossing in Southeast Asia, completed last year, 30 kilometers of new bridges connecting Temburong to the main part of Brunei. So very extensive project involving, as I said, probably 100 men, multiple spray machines, nearly 2,000 tons of material, all shipped from the UK in very quick time. So very proud of this one. We do again have a short video, but just to give you guys from an engineering background to see the extent and scale of this. It sort of mirrors some of the jobs that you guys are doing at the moment in Mumbai, for instance. So it might be interesting for you to see how it will look when it's finished. So, Mr. Bhavan, if you could take the floor again and just show the final video, and that will conclude today's presentation. Thank you so much.
Yes, Mr. Bhavan, yeah.
Is the audio there?
Yeah, we can see. No, but the video audio is not there. Yeah, it is there.
Bridge project is quite simply a one-off. It's one of the largest bridge projects in the world. It's in the top 10, and at the moment it's the longest sea crossing in Southeast Asia. The entire length of this project is 30 kilometers. Compare that to the longest bridge in the UK. It's 6 times the length of the Second Severn crossing. So having done the Second Severn crossing 25 years ago, to deliver a project of this scale, you can imagine how proud we are as a business. The waterproofing system that you can see around me is called PMB, which is a 2-component spray-applied polyurethane system. Pitchmastic's involvement is to supply and install our PMB system. Pitchmastic are not only supplying a world-class material, we're also installing it using our trained and highly skilled people. That sets us apart from others in that we don't just sell products, we manufacture it, we formulate it, we deliver, and we install, and we quality test and verify on site. prior to the bridge, the only way to get across was quite an arduous ferry run or a 2.5-hour drive through Malaysia. So clearly the project is connecting families, communities, and it will be a legacy project for His Majesty the Sultan. We can tackle a job of this size, of this extremity. It's a magnificent civil engineering project that we're very, very proud to be involved in. The USL Group is the pinnacle of 6 years hard work, and we're very fortunate to have been awarded the contract for the entire bridge. So we can proudly say that we're doing every square metre of this project, and we're delivering a quality, professional service to the ultimate client, the Ministry of Development. The USL Group has some fantastic people, and none more so than the guys in Temburong, and also the people that we work with who've made a lot of self-sacrifices, worked here for extended periods away from their families, and we're very thankful for those people who have made sure that the project has been a success, and everybody on the team must be very, very happy with their performance.
Yeah, thank you, Bhavenji. Mr. Pike, are you over? It's finished?
It is concluded now, so I'm open for any questions from the panel and anybody out there.
First of all, thank you very much, Engineer Pike.
Pleasure.
And special thanks to Mr. Bhaven Kothari ji for helping me out all the videos and all. Bhaven ji, can you switch on your video if permit? Hi, Bhaven ji, can you unmute yourself? Can you unmute yourself?
I said namaste to everybody, sir.
Namaskar. Mr. Anil Anjappa ji. Yeah. Hi, Anil. Anil, can you unmute yourself?
Yeah. Thank you, Gopal. Anil here.
Yeah. Before we go to today's panelist, let me thanks to Bhaven ji and Anil. Anil, can you say a few words?
Yeah, firstly, I would like, on behalf of TREMCO and the USL, I would like to thank the IIBE for giving this opportunity for presenting this technical session. That's a special thanks from our side, from my entire team, especially Gopal and Vinay Gupta sir and the chief guest and the panelists for being here. And I think this is a technology which we are speaking from last 1.5 to 2 years in India. We're just hoping that we should be able to work with some of the prestigious jobs happening across the country, and I'm sure that we'll make, if it can be done in Southeast Asia or any other country, I think definitely we'll be able to deliver in India also. So we're looking at working with some of the projects. I'm sure we'll make it happen. Thank you, Gopal, and the entire team of IIBV for giving us an opportunity.
Once again, thanks to Mr. Pike, Bhavenji, and Anilji. Now, it's my duty today's the panelist. Let me hand over to today's panelist to overview, and he can ask a few questions to our own engineer Goyalji. Can you? Yes, sir.
Yes. Thank you, Dr. Gopal Roy. It's a wonderful presentation, I would say. A very good technology, very innovative concept of spraying a waterproofing membrane over the bridge deck before going for the wearing coat of asphalt. A very question comes to my mind. Actually, it is whatever has been presented, it is for the new bridges. And we in railways basically are dealing with many problems on the existing ROBs. So if something can be covered on the problem of leakage or problem of seepage through the existing decks, what kind of solutions are there available in the world? So that would go a very big way, and it will be very useful for the practicing maintenance engineers. So I hope something will be taken note of it, and in future we may have a separate lecture on that topic of existing bridges. And a request has come from 2-3 participants about sharing of the presentation. I think IEB can take a call whether to share or not to share. In my opinion,
yeah, it is there on the YouTube, sir. This is live on YouTube, so you can download the things.
Okay.
Yeah.
Now, I will take a few questions which probably Mr. Pike can answer live. Actually, there are two questions from Mr. Manjul Mathur, who is also CBE in Western Railway, dealing with the maintenance of the bridges. Very valid question. First is about the quality. If you want to ensure the quality work, then it is always desirable that the complete work of supplying the material, its transportation, its surface preparation, and then complete execution, if it is done by the manufacturer or his authorized representative, you can be assured about the quality work done. Otherwise, what happens? Somebody else, if he is using, he may not apply the material in a desired manner or as per specification. Ultimately, if there is any failure, the technology gets the blame, which is very wrong in my opinion. So there has to be a system in which the complete product is manufactured, supplied, installed, and rather applied and handed over to the owners in a perfect fashion with the maintenance requirements, if there are any, the instructions on that. So this is a question. Do we have supply material alone or complete solution including the installation in India, particularly in India? You may have such suppliers or such installers in other countries, but in India, do we have such firms?
In short, yes, we do. Just very briefly, USL Group are a contractor. That's one of our main functions. We are a contractor as well as a manufacturer, but our origins are contracting. So we're very much involved and ultimately responsible for works that are done, whether it's India or anywhere else in the world. The works that are being done at the moment in India are under close scrutiny from our company. We have technicians who are based on site, who will supervise the works, and we will sign off the applications as and when they're done. The project that you saw, or two of the videos that you saw, one of them was in Turkey, again, where it's our own company, individuals, skilled people doing the work, supplying the material, doing the work, signing off, doing the quality checks, and giving the appropriate warranty to the end user. And in Brunei, the Temburong Bridge, once again, it was our subcontract, our people, and obviously, again, the ultimate client had the benefit of one solution. Any problems, one company. No hiding place, no running away, no hiding behind certificates or contractors, no blaming local contractors. It was down to us. So that is the basis that we'll be looking at for India. Obviously, Tremco are part of our business. We're part of the same entity. So there's no dilution of control there. And that's what we're offering to the customer. It's not just a material, it's a service.
So the answer is yes, Mr. Manjul. Answer is yes. And the second question from Mr. Manjul Mathur, and I also feel it's a very relevant question. Mostly again, in maintenance, we have noticed the problem of leakage through the deck slab is along the curb line. That is the junction of the footpath and the main deck. So is there any possibility that when we do this waterproofing by spraying this chemical, we do it along the most important area, along the curb line in a strip, say? Or would you recommend that it should be done all over?
I'm sorry that the presentation covered quite a few new build projects, but our experience is mainly maintenance, to be quite honest. In the UK, they don't build many new bridges they haven't done for a long, long time. So most of our works over there is maintenance. So exactly what you said about refurbishment of existing structures, cleaning off the old material, doing preparation, doing repairs, and applying the system. So I must make a note of that for next time. But in terms of the waterproofing detail, yes, of course you can do a strip along the curb line. That might be very useful. But leaving a section in isolation without continuity is not a good idea. Eventually that section may become vulnerable to damage. Water could probably seep through the concrete in the main deck. So generally the detail is you will go curb to curb, up the upstand, and you will terminate the waterproofing up the parapet, up the jersey barrier. So it will waterproof the entire exposed surface, both underneath the asphalt and in the footway as well. That will give you continuity, and it will give you a complete watertight solution.
Mr. Pike, in case somebody wish to do it all over the width, then what are the cost implications? Rough idea about what is the per square meter of cost of this waterproofing?
Yeah, the cost side of things really depends on many different variables. I mean, we just provide the materials to Tremco. What Tremco can do, if you want to talk about this on a separate call, is they can give you some budgets and prices for this. But it's certainly not comparable to bitumen systems. It's more expensive than that initially. But we're not talking about initial costs. We're talking about long-term value for money. And obviously, if something's going to last you 30, 40 years that doesn't need replacing, then obviously the cost initially is actually far less than you're currently spending at the moment with alternative materials. So, yeah, certainly we can talk about pricing, but probably not on this forum today.
Okay.
Yeah.
And as you have said that service life, the service life is around 30 years or 20 years, then how to replace it then, this waterproofing layer?
What would normally happen, sir, is we would recommend they apply 2 layers of asphalt above the waterproofing layer. So when it's time to replace the wearing surface, which is normally the surface that's obviously more vulnerable, plane off the top layer of asphalt, leave the base layer and the waterproofing intact, and just replace the wearing course. Then there's no need to replace the membrane. The membrane will still be intact, and then you just replace the wearing course when you need to. So it just gives you that extra cycle for the durability. If it does become damaged, then you can repair areas quite easily. But as I say, if you stick to the rule of applying 2 layers of asphalt, then you can always replace the second layer. If it's 1 layer, then you'll be damaging the waterproofing, and you need to do that a lot more carefully.
That's right. So in any case, one has to be very careful while removing the top wearing coat during the replacement stage.
They do.
Okay. And patch repair of the membrane is possible.
Correct. Yes.
Right.
I think, yeah, there are a few more questions. If Goel sir, if you permit, can we?
Please.
Yeah, Mr. Pike, if you can go to the question box, question answer box, you can read the question. I will will talk the question. Before we go to the question on the chat box, let me ask to our Director General, Mr. Divte is there. Divte sir, Engineer Divte. Hello, can you hear me? Can Divte sir unmute yourself?
Yes.
Can you give your short opinion, sir, on the waterproofing aspect? Divte sir, we can hear you. Yes, sir. Can we have a short opinion? Our Director General, Divte sir.
Hello.
Yes, sir. We can hear you.
Leakages from, actually I joined little late, for that I'm sorry. I was outside and I came little late.
Yes, sir.
However, whatever I heard, it was a excellent presentation, very, very useful. And the problem of leakages from the deck is very serious problem.
Okay.
Which engineers are facing to repair the deck and prevent the corrosion of the steel members, steel components. So it is very serious problem. So from the today's presentation, I think we got a lot of useful information and will be helpful to all the engineers to take care of the bridges.
Thank you, sir. Let me request Engineer Atul Bobeji from TPF, the MD of TPF. Atul, sir.
Thanks, Dr. Gopal Rai. Adrian, first of all, as usual, a wonderful presentation. Congratulations. Very well explained. The video that you showed for the Bosphorus Bridge, actually, I thought maybe a slight comment from your side would help, because I think that video was about replacement of the waterproofing layer for a bridge that's already running.
Correct.
Right? It's being done under traffic, if I understand the video right. So maybe if you would explain a little bit about that, it might help the understanding of people what exactly was done. That's first comment. The second comment is that we specified this system, not this particular system, but a similar system, an MMA system for the Mandavi Bridge in Goa, and that was specified in the year 2015, 5 years back. That's been executed already. Almost 65,000 square meters of membrane has been laid. Substantial experience has been generated in India with that. That was done in the year 2018, late 2018 and early 2019. So it's already seen one monsoon. We have had no major problems. There have been minor issues of potholing, but very minor. On 65,000 square meters, we've seen maybe a few square meters here and there which showed potholes, but by and large, the experience has been very good. That experience is now being compiled in the IRC specification that's being drawn up that Adrian showed you, a page of which was shown. That's probably the first bridge in India where a waterproofing membrane of this kind has been used. It's also specified for the Zuari Bridge in Goa and another bridge, an elevated corridor of 9 kilometers in Goa. So these three bridges were perhaps one of the first bridges where such a waterproofing system was mandated. It was done, like I said, in the year 2014-15, and now all three bridges are under execution. Mandavi is already completed, open to traffic. Zuari is under construction, probably will be open to traffic. One lane will be open to traffic next December, I hope. And the elevated corridor is nearly ready, and we'll see waterproofing being done maybe in a couple of months. And will be opened hopefully by March. So that's for people who want to know whether such a waterproofing system has been executed in India. Yes, it has been executed, but not exactly the one that Adrian talked about. Adrian talked about 4 or 5 different systems. The one that's been used in Goa is the one with MMA, not the PU system that Adrian talked about. Thanks. Thanks, Dr. Gopal.
Thank you very much, sir. Mr. Pike, there are a few questions are there. Let me read out the question. There's a question from Vidi Sharma. Engineer Vidi Sharma is also IIB, the senior member. He has asked, how do you suggest to negotiate moisture content less than 6% in the area where humidity is around 90% while application of the system?
Yes, a good question. Obviously, concrete will retain moisture if there's a lot of humidity about, but basically we use compressed air just to dry the concrete. And it really depends on the mix design. If you're using a sort of C50 mix, typically with a water cement ratio of about 0.45, the surface moisture will come out, and typically after about between 4 and 7 days, it will be acceptable to apply the system. As I said, we did the whole of the job in Brunei with humidity not around 90%. You're in a rainforest. There can't be much conditions worse than that. it rained every day. But once it stopped raining, we quickly blew off the excess water, and then we could start spraying fairly soon afterwards. So these are considerations for any project. They do cause some delays, but provided the guys understand what they need to do, then we can deal with that as an ongoing basis. So the moisture is not an issue, provided the surface is dried. And obviously humidity, again, is monitored. But as I say, we've worked in nearly all climatic conditions now, and it's really the rainfall that stops you rather than the humidity.
Yeah, I think looking at a few questions Mr. Sachin and Naveen ji has asked, I will request Mr. Paik if you can share some technical literature to IAB on the methodology, analysis, and some literature, so that we have in quarterly we publish some the magazines. Okay, so we can consider your the technical, because a lot of question has been asked on the case study and analysis. Right now we'll not cover that part, but if you can share some technical literature, we can upload to our website and the magazine.
Certainly will.
So the second question, Mr. Samir is asking, if you require to do second time similar waterproofing after service life of 20-25 years, then what will be the method adopted?
Yeah, it's a good question. Obviously, we've been applying these types of systems for probably 40 years now. So we do come across bridges that we've done 20, 30 years ago, and we've got to do, it may be an extension to that structure, there may be a new footway or a new lane being applied. So yeah, the main thing is the overlap. We expose the existing waterproofing, and we have to prepare at least 100 millimeters of the existing waterproofing. So we'll clean that, we'll remove any bitumen, we'll make sure there's no damage on that existing overlap. We clean it with a wire brush, and then we use a solvent to clean the surface, and then we apply primer and the waterproofing. We also do a bond test on the overlap to make sure that the two materials are adequately bonded together. So it's quite straightforward. It's obviously something we encounter a lot, both on existing projects and new projects where there are big gaps between the work phases. So hopefully that explains it.
Yeah, I think on the similar line, Manish has also asked that whether this wearing coat has a life of 4 to 5 years. So whether the resurfacing will damage the waterproofing. I think Manish Gupta, yeah, he has asked.
Yeah, again another good question. Yes, I'm aware.
It is a life of wearing course. If you can see that question, life of wearing course is normally 4 to 5 years.
Yeah.
Doesn't the waterproofing get affected during the resurfacing?
Yeah, I sort of touched on this earlier on, that I'm aware that obviously there are life cycles of existing materials in India, and I know that there's certain bodies that's looking at the type of materials that's used for asphalt, using polymers, polymer modification, for instance, because certainly 4 to 5 years is not a long time for asphalt. You know, in the Middle East here, we get in at least 10 to 15 years life. But nevertheless, if you've got a wearing course that needs replacement, as I said before, the ideal scenario, if you apply 2 layers of asphalt, the wearing course and then a base course below it, just remove the wearing course when you need to, and then you won't disturb the waterproofing underneath. If for some reason you've only got the wearing course, then you'll have to carefully remove that wearing course, inspect the waterproofing, carry out any repairs to the membrane, reapply the tack coat, and then you would apply the asphalt over it. So in both situations, if it's done carefully and you involve the waterproofing manufacturer, then it would mean that you won't have to replace the entire membrane every 5 years, which is obviously an expensive exercise.
Yeah, I think well said. And there's a Rishikesh Singh. He has asked the question: what is the segment top slab roughness required of the segment prior to waterproofing?
Yeah, we can apply onto obviously new concrete or old concrete, and the surface texture really has nothing to do with bonding or a technical reason. It's purely to do with the consumption of the material. The harder the profile, if it's irregular the profile, you will tend to use more material. So commercially, it's more expensive. So if you're building a new bridge, we would like to see a steel float finish. And in the UK, they have a specification called U4, which is either a wood float or a steel float, and then obviously with abrasive blasted. So that's the sort of texture that we're looking for. We don't need it to be tamped like you do with a lot of the bitumen systems, because that will just cause more consumption. So generally speaking, like a sandpaper finish is acceptable.
I think people have appreciated your presentation. That's a good part. There is one question which I feel I should ask, like the patch, if you do with this type of membrane, whether we get a patch, bad patches in the bitumen or not. I think there are 2-3 repeated questions. Can you comment on that?
If you're talking about if there's repairs in the asphalt to do. Sorry.
Sir, you muted.
Okay. Sorry. Thank you, Ruhi. There is a question on the patch, the bridge patch. Okay. Whether after doing this waterproofing, we'll not get any patch of the potholes in the bridge deck and all.
Yeah, I mean, the gentleman mentioned Mandovi Bridge before. I mean, generally potholes are caused by water, and they're caused a lot of the time due to drainage, but also due to areas where the bonding between the asphalt and the waterproofing is not so good. But drainage is very important, and bridge water management is important. So if there is good drainage on a bridge, it will avoid the pressure buildup, especially at expansion joints and low points, which can lead to hydrostatic pressures. What these new membranes are doing is providing complete waterproofing. So the water will not go down; it will come up. So if the water is allowed to pressurize and there's not enough drainage, then that can lead to pressurization. So you can resolve that by drainage, using finely graded overlays. So when the rain hits the wearing course, it runs off the camber to the drainage and away. If you use porous asphalt materials, the water will penetrate the asphalt very quickly and cause hydrostatic pressures. So it's important that you discuss your asphalt mixes with the waterproofing specialist to get the right combination, because this is not a bitumen system. It won't allow water through it. There's no overlaps, there's no weak spots, so any water that gets down there needs to be dealt with, and it's something we've learned in many years, that it's all about water management, and there are different ways of doing it, and we've got some good solutions.
Yeah, there is one question, very interesting question from Mr. Abdullah. If leakage happened to the upper surface, should we have to keep the slope? He's talking about some slope on whether we have to keep slight slope to the membrane or the deck regarding the slope philosophy. You can go to the last question. Okay. There is a question on the slope part. Can you comment on that?
Okay, yes.
Yes.
Yes, I mean, obviously the bridge will be laid to some sort of falls. But the big problem that we've seen is that there's a lot of drainage at surface level with the asphalt, but there's very little drainage at the deck level. So there are drainage systems that you can use at deck level, either positive, which goes straight through the deck, or using a combined surface and subsurface drainage unit. And that would mean that the water will be taken off the bridge from the wearing course level, and any water that gets down to the waterproofing layer can also escape at surface level. So it's something to consider. I know that in Brunei, they put some drains in at the waterproofing layer in the curb rather than at surface level. And it was very important because obviously they get rain every day. It's like monsoon every day in Brunei. So they needed to make sure they got rid of the water quickly. But in terms of falls obviously there'll be falls on the asphalt, which are typically 2%. And obviously if you've got falls on the bridge, great. And you need to put drainage at the low points to get rid of the water.
I think there is another question which is on applying the right thickness, how to check whether the thickness is proper or not while doing the application. The thickness of,
Yeah, so what we do is we undertake thickness checks every 20 square meters typically, and that involves taking a sample of the membrane in its semi-cured state and taking it with a micrometer. If for some reason that area is not the correct thickness, then the area is second coat is applied over that area. So all of this work is done while the membrane is still in a sort of semi-cured state. So the checks are done every few minutes. So it avoids a problem at the end of the day. And it means that it's constantly monitored. The application is constantly monitored from the start straight through to the completion. Various people are inspecting that. So that will verify the thickness is there. In addition, the machinery that we use has computers on the back, and they will show you how much material is applied. So you can also do a check for the surface area versus the amount of material that we've applied to verify that the right consumption is being used. And finally, the pinhole test that we do is set for 2 millimeters. So if the material is below 2 millimeters at any location, the voltage will blow through it and it will create an alarm. So again, it's another check to make sure that the guys have put the right thickness down. Okay.
Yeah, I think we have covered more or less all the question in some way. But Engineer Pike, I will really appreciate that this is you are the third speaker in 8 series who has crossed more than 25 questions in the webinar part. I think big clap to you, boss. This is the best. More question means the people are interested more. There are some questions that if in future, if you can cover the rehabilitation part also. Okay, for the old bridges, how you have done the things. If you can cover such bridges also, that will be welcome. But really, we look for a good technical presentation, good technical paper from your side, where the structural consultant and the authority like Goyalji from Indian Railway and NHI and all the people, MMRDA. Let me say that close to 100 people on the portal and close to 140 people on the YouTube have gone through your today's talk. And the best part, people are still there to listen to your question and answer. That is the best part. And really, we thank you for coming and giving a talk on such a subject which we really ignore sometime. Okay, so it should not be ignored. Before, I have a habit of giving shairi on every subject. So today just I have written, but I will tell in English, then I will translate in English, Hindi. Okay, so for you especially, getting drenched will lead to fever. Getting drenched will lead to fever. Good waterproofing will keep you away from retrofitting. Okay?
Very good, very good.
So this is, although I'm in a profession of retrofitting, I'm trying to sacrifice my part. Okay, but in Hindi when I will tell, पानी में भीगोगे तो बुखार होगा, पानी में भीगोगे तो बुखार होगा, वाटर प्रूफिंग अच्छा होगा तो रेट्रोफिटिंग का नामो निशान नहीं होगा. So that is the part. So this is just little limelight or little Bollywood into the IIB also. Always Bidesa want romance in bridge engineering, so light moment. Yes, we do appreciate, and really and Swapnil is not there, he is occupied with some meeting, and engineer Vinay Gupta has given the president of IIB has given the regards to you, and he is occupied in some the committee meeting with NHI, so he has thanks to you for giving a lecture, so please accept his regards and all. Let me formally, I think we have done a very good webinar lecture 8 series. Rui, can we present for the future? What are the, in next webinar is coming? So I can give 2 minutes there. Then I will give a vote of thanks. Yeah, this is the future coming webinar on Gandhi Jayanti, 2nd October. We have chosen a date, and the subject is health monitoring of bridges by stalwarts of country. Okay, really, if you see the name, the GK Sahu sir, professor from CSIR, then Professor Sanjay Chikarmani from IIT Roorkee, then Dr. Sanjay Suresh Bhalla from IIT Delhi. I think there is a correction. It is from IIT Delhi, and Chikarmani is from IIT Roorkee. And then Lieutenant Colonel Harshad Chatty, who is working with TPF. Then Engineer Sahil Matre from DGC Engineering Private Limited. So this will be like 3 hours webinar, and a good manthan or good discussion on the monitoring of the bridges. And these all 5 stalwarts will give a case study also what they have done in country. And really this will be like, if you want to check the heartbeat of the bridges, you should not miss this webinar. Okay, so all the students, all the professionals, and it is on holiday, intensely it is kept on holiday, so that we can check the heartbeat of every bridge, and also we can check how we can check the heartbeat also. That is the thing. Let me now formally go to the vote of thanks. Swapnil has given all regards to all the people. Let me first thanks to our Director General, Engineer Dyute Sahab, for coming and giving the few words. Thank you, Dyute sir, for giving the few words and sharing part. Let me thanks to our President Vinay Gupta ji. Although he joined for initially for a few minutes, then he left, but he has given high regards to all the speakers and everyone. Let me thanks to Engineer Swapnil Joshi for welcome address and giving the valuable time. And the special thanks to today's speaker, Engineer Pike, okay, for giving a very good videos. In fact, video tells 1,000 words. Okay, so and in that I will also thank Bhavenji for helping us and showing all the videos. Otherwise, without video, it is incomplete. Thank you, Bhavenji. And a special thanks to my one and the only friend, Anil Anjappa. Okay, thank you, Anil, for giving such a topic which is never discussed. And yes, in the future we'll discuss this part also repeatedly. As I told that if good waterproofing will lead to away from retrofitting. Okay, I'm ready to sacrifice the retrofitting part so that a good waterproofing should be done. Thanks to our panelists today, Engineer Goyalji. Thank you very much for your valuable time. And let me tell to all the attendee and all the people, I find Goyalji, he go to the such a subject depth and he enjoys the engineering. That is the best part of Engineer Goyalji. Thank you very much, sir, for sparing time for the all the webinars and all. Let me thanks to Atul Bhobe sir for giving his valuable comment and hand-on experience with his own design and in the bridges. That adds to the confidence to the attendee and all the people, because people think that it is done in the outside the boundary, but it is done within the boundary also. So that's a good part. Thank you, Atul sir. I think for a few minutes, Manjure sir also has joined us. but I was trying to find out him. Otherwise, I could have taken one question from him also, Senior Manjune sir. Okay, thanks Manjure sir for joining. Let me thanks to the USL Group and the Tramco from India for giving the brief introduction and sharing all their case studies and all. Special thanks to Deepika Singh, who has overall, she is the host for this, and she is also an engineer and planning and all this. Thank you, Deepika. And none other than Ruhi, the coordinator for IIB. And with his presence, we have done, this is our 11th webinar or lectures, you can say. Congratulations, Ruhi, you have went to the 2-digit part of the webinar. That's the best part. And thanks to Josefa, the host, the webinar part, he always there with us. And with all permission from the speaker, panelist, let me formally, and the best part from last 2 webinars, we are seeing that we are starting on time and we are closing on time. So with this note, I thank you all and see you on 2nd October, Gandhi Jayanti with IIB. Okay, on the health monitoring of bridges. Don't miss this opportunity, and really you will love this. Never this all stalwarts on one forum never talked. Okay, so this is the first time we have invited all the stalwarts of the country in one forum. So with this folded hand, I thank you all. Thanks to all the people who have joined us, and Jai Hind.
Thank you, Gopal.
Thank you, sir.
Thank you very much indeed. Thank you very much.
Thank
Bye.
you.
Goodbye.
Bye-bye.